At the heart of the Catholic intellectual vision is that faith and reason have a mutually illuminating relationship to one another. That is why one of the ideals of a Catholic education is to provide opportunities for our students to interact with different disciplines in an integrative way in their search for truth. Pope John Paul II says it very well in his encyclical Fides et Ratio. He begins that letter with this: faith and reason are like two wings on which the human spirit rises to the contemplation of truth, and God has placed in the human heart a desire to know the truth, in a word, to know himself, so that by knowing and loving God, men and women may also come to the fullness of truth about themselves. Before we introduce this evening's speaker, I just want to convey some thanks. First, my thanks to my colleague, Kelly Klein. Last year, when I sent out some articles to faculty on the Catholic intellectual tradition and different disciplines, Kelly was very gracious to send me an email about one of those articles, and it generated a conversation that resulted in tonight. And so our guest speaker is here tonight at Kelly's recommendation about a year ago. I think at this time is when we started this conversation. And this evening could not have happened then without the support of some very important people here at Carroll. So my gratitude both to Kelly and his colleagues, Mary Keefe and Tony Spilka in the physics program, to the Annette Moran Center and John Reese for its support, the Office of Academic Affairs, Kathy Day, for her support, Patrick Harris and Student Affairs for their support as well. And also I want to thank Dr. Eric Hall, who has put the yeoman's work in putting this all together this year. And with that, I will invite Dr. Hall to come forward and introduce our guest speaker this evening.
So I've had the pleasure with hanging out with Dr. Barr all day. We've been talking, well, everything from afterlife to the neglect of Lonergan within the academy. So really anything, except for physics, because I can't do that. So I appreciate his ability to talk in philosophy in a way that I cannot do in his discipline, his primary discipline. Stephen Barr is an author and professor in the Department of Physics and Astronomy at University of Delaware and a member of its Bartol Research Institute. He does research in theoretical particle physics and cosmology. In 2011, he was elected Fellow of the American Physical Society, the citation reading for original contributions to grad and unifier theories, CP violation, and baryogenesis. Barr writes and lectures frequently on the relation of science and religion. Since 2000, he has served on the editorial advisory board, now the advisory council, of the religious intellectual journal First Things, in which many of his articles and books have appeared since 1995. His writings has also appeared in National Review, The Weekly Standard, Modern Age, The Public Interest, and Commonweal, and I'm sure many more. In 2002, he gave the Erasmus Lecture sponsored by the Institute of Religion and Public Life. In 2007, he was awarded the Benemerenti Medal by Pope Benedict the 16th. Took me a second there to read a Roman numeral. In 2010, he was elected a member of the Academy of Catholic Theology. His contributions to physics and the natural sciences are numerous, and we're very fortunate, I think, to have such an accomplished physicist on the campus today. I'll let you ask him about his work on such issues such as flipped SU5 scheme of unification grand unified theory, identifying the bar-Z diagram and proposing the so-called Nelson-Bar mechanism as a solution to the strong CP problem. His theophilosophical contributions are also quite substantial, as Dr. Barr has written Modern Physics and Ancient Faith, Science and Religion, The Myth of Conflict, and he's going to be presenting more or less a lecture based on this latter book that he's written here tonight. And it's for that reason that we've truly invited him. So with that, I want to please give Dr. Barr a very warm welcome.
Thanks, Eric, and thanks for inviting me, and thanks for turning out tonight. Can you hear me if I speak like this? Okay, good. How many people recognize that clerical gentleman standing with Albert Einstein? How many? Raise your hand if you know who that is. Ah, good, because then I'm going to teach you something. At least one thing tonight. There's a widespread perception that there's some kind of conflict between, or contradiction, between science and religion. Atheists confidently assert that there is, and many religious people fear that there might be. This has helped undermine the faith of many people. Now, certainly, some religious beliefs do conflict with science, but why is there a perception that all religion per se, is contrary to science? I think people are mistaking one thing for another. There is a real, long-standing, and often bitter conflict going on, but it is not between religion and science. It is between religion and a philosophy called scientific materialism. Scientific materialism is an idea that grew up alongside of science, it was inspired by science, and wraps itself in the mantle of science. It is the worldview of many scientists and of some people who presume to speak for science, but it has no claim to being science. It is rather a philosophical idea. The central tenet of scientific materialism is very simple, and this simplicity accounts for much of its appeal. It is that the ultimate reality is matter, so that everything that exists and everything that happens can be explained by the laws of physics and blind chance. For some of its adherents, however, scientific materialism is more than this. It's a passionately held ideology that sees itself as having a saving mission, which is to free the human mind from irrationality and superstition, among which they count religion. It's not enough that science is good and brings us understanding. There must be an enemy to be vanquished, and they cast religion in that role. This explains the strange zeal that some materialists have in propagating their ideas. They feel that they're taking part in a grand struggle between reason and its enemies. This gives their lives a heroic meaning and purpose. Scientific materialists have a well-developed critique of religion which has at least three aspects: philosophical, historical, and scientific. Their philosophical claim is that there is an inherent contradiction between the scientific and religious outlooks. Science is based on reason and evidence, whereas religion, they say, is irrational because it is based on dogma, faith, and mystery, which involve belief in things that cannot be seen and for which supposedly there is no evidence. Science is based on natural explanations and natural laws, whereas religion is based on miracles and the supernatural. They see religion as a matter of myth and magic, and therefore pure superstition, which is the very antithesis of a rational scientific outlook. Their historical claim is that religious believers and institutions have been hostile to science and have tried to suppress it. I don't think I need these. Maybe my eyes are getting better. I don't know. This is powerfully symbolized in the eyes of many by the Catholic Church's treatment of Galileo. And this impression is constantly reinforced in the public mind by the battles waged against evolution by biblical literalists. Their scientific claim is that the actual discoveries of modern science over the last 400 years have debunked or undermined fundamental Christian beliefs about the universe and mankind's place in it. As the story is often told, science has dealt one blow after another to the religious conception of the world. Copernicus showed that human beings are not at the center of the universe. Newton showed that the world is governed by blind and impersonal forces. Modern astronomy showed how small and insignificant we are compared to the cosmos as a whole. Darwin, they say, showed that humans differ only in degree from lower animals. Discoveries in fields such as neuroscience and artificial intelligence are expected to show, if they haven't already, that the supposed soul is just the working of the brain, a complex biochemical computer. And modern cosmology is invoked to show either that the universe had no beginning or that it had a beginning, but that it created itself out of nothing by a quantum fluctuation. I'll deal with each of these strands in turn. So first, the philosophical. The philosophical critique is largely based on crude misunderstandings of traditional ideas about God and creation. Let's start with supernaturalism. Christianity and Judaism were never based on supernaturalism, if we mean by that the rejection of the idea of a natural order. Indeed, scholars say that the book of Genesis was in part an attack on the supernaturalism and superstition of ancient pagan religions. When Genesis said that the sun and moon were merely lamps placed by God to light the day and the night, it was attacking the paganism that worshipped the sun and moon. When it said that man was made in the image of God and was to exercise dominion over the animals, it was, among other things, attacking the paganism in which men worshipped and bowed down to animals, or to gods made in the image of animals. In paganism, the world was imbued with occult forces and populated by numerous deities. But Jews and Christians taught that there was only one God, who was to be sought not within nature, not within its phenomena and forces, but a God who was outside of nature, a God who was indeed the author of nature. In this way, biblical religion desacralized and depersonalized the physical universe and made it indeed into a natural world, and thus helped to clear the ground for the later emergence of science. The biblical religions then taught that there is a natural order which comes from God, and what characterizes this natural order and reflects the wisdom and rationality of its creator is precisely that it is orderly, harmonious, and lawful. Consider this passage from the famous letter of Clement to the Corinthians, written about 97 A.D. The heavens, as they revolve beneath his government, do so in quiet submission to him. The day and the night run the course he has laid down for them. Sun, moon, and starry choirs roll on in harmony at his command, none swerving from its appointed orbit. Laws of the same kind sustain the fathomless deeps of the abyss and the untold regions of the netherworld. The impassable ocean and all the worlds that lie beyond it are themselves ruled by the like ordinances of the Lord. Upon all of these, the great architect and Lord of the universe has enjoined peace and harmony. Or consider this passage from the Christian apologist Minucius Felix, writing around 200 A.D. And he was writing, this is a book written aimed at pagans to convince them to believe in a creator God. If upon entering some home you saw that everything there was well tended, neat, and decorative, you would believe that some master was in charge of it, and that he was himself much superior to those good things. So too in the home of this world, when you see providence, order, and law in the heavens and on earth, believe that there is a Lord and author of the universe more beautiful than the stars themselves and the various parts of the whole world." Unquote. So it was not the supernatural or miraculous departures from the order of nature, but the order of nature itself and its lawfulness that were seen as pointing to its creator. The ancient argument was that if there is a law, there must be a lawgiver. God was the lawgiver not only to Israel, but to the cosmos itself. I guess we can go to the next slide, so people won't read that for the rest of the God was the lawgiver not only to Israel, but to the cosmos itself. God says in Jeremiah chapter 33, verse 25, "When I have no covenant with day and night and have given no laws to heaven and earth, then too will I reject the descendants of Jacob and of my servant David." Psalm 148 tells of the sun, the moon, the stars, and the heavens obeying a divinely given law that will not pass away. The idea of God as rational lawgiver very likely helped give birth to modern science, as even some atheists at times concede. For example, the eminent biologist E.O. Wilson suggested the following as the reason that Chinese civilization, for all its impressive achievements in science and technology, did not produce a Newton or Descartes. Quote, Chinese scholars had abandoned the idea of a supreme being with personal and creative properties. No rational author of nature existed in their universe. Consequently, the objects they meticulously described did not follow universal principles. In the absence of a compelling need for the notion of general laws, thoughts in the mind of God, so to speak, little or no search was made for them, unquote. And the well-known cosmologist André Linde, an atheist, has suggested that the notion of a universe governed by a single law in all its parts is historically rooted in monotheism. Now, Christianity does, of course, teach that there are supernatural realities, such as divine grace, that have effects in the world. But the word supernatural, which means above the natural, would make no sense unless there were a natural order in the first place. And the concept of miracles, which are extraordinary events that go beyond what is naturally possible, presupposes that there's a natural order that determines what is naturally possible and what is not. There's no logical contradiction between the idea of miracles and the idea of a lawful universe, for the same lawgiver who established the laws of nature can also suspend them. There's much confusion today, even among some Christian believers, about how nature relates to God. Instead of seeing God as the author of nature, they see God and nature as somehow opposed or in competition. So that if something has a natural explanation, then God has nothing to do with it. And conversely, if God is the cause of something, then it must be supernatural. Many therefore look for evidence of God only in what is outside the course of nature, or inexplicable by science. That is, in the gaps in our scientific understanding. Hence the expression, the God of the gaps. And atheists think that by closing those gaps, they'll leave no place for God to hide. The traditional Christian and Jewish view was quite different. If God, as creator of the natural world, established its laws and gave to things their natural powers, then his existence is evident in nature itself and its ordinary processes, whose power and working reflect God's own power and wisdom. This is the message of the following passage from the Book of Wisdom, a Jewish work of about 100 BC, which is recognized as part of the Bible by the Catholic and Orthodox churches. For all people who were ignorant of God were foolish by nature, and they were unable from the good things that are seen to know the one who exists, nor did they recognize the artisan while paying heed to his works. But they supposed that either fire or wind or swift air or the circle of the stars or turbulent water or the luminaries of heaven were the gods that ruled the world. If, through delight in the beauty of these things, people assumed them to be gods, let them know how much better than these is their Lord, for the author of beauty created them. And if people were amazed at their power and working, let them perceive from them how much more powerful is the one who formed them. For from the greatness and beauty of created things comes a corresponding perception of their Creator. Yet these people are little to be blamed, for perhaps they go astray while seeking God and desiring to find him. For while they live among his works, they keep searching, and they trust in what they see, because the things that are seen are beautiful. Yet again, not even they are to be excused, for if they had the power to know so much that they could investigate the world, how did they fail to find sooner the Lord of these things? Oh, I have more in my talk than in the slide. This, by the way, is the one passage in the Bible that is essentially directed at scientists. It's really the one passage that addresses science. And I often, when I see my colleagues who investigate the world and see the beauty of created things fail to find their author, I wonder about it, the same as the author of the Book of Wisdom. Notice that the evidence of God to which this passage points consists of phenomena that are perfectly natural. Fire, wind, swift air, the circle of the stars, turbulent water, and the luminaries of heaven, that is, the stars, planets, sun, and moon. Medieval theologians distinguished two ways, Medieval theologians distinguished two ways in which God acts in the world. He can act directly in a supernatural manner, for example, turning water into wine, or he can accomplish his will through the operation of natural causes and processes. It has always been the Christian view that God ordinarily acts in the latter way. In the words of the 17th century Catholic theologian Francisco Suarez, quote, God does not interfere directly with the natural order where natural causes suffice to produce the intended effect, unquote. This principle was important for the founding of science, for it implied that when confronted by some puzzling event or new phenomenon, we should look first for natural explanations. Superstitious people tend to see the supernatural in every unusual or strange event. But this was strongly criticized by the great medieval theologian and scientist Nicholas Orem. In explaining the marvels of nature, he said, quote, there is no reason to take recourse to the heavens or to demons or to our glorious God as if he would produce these effects directly, any more than he directly produces those effects whose natural causes we believe are well known to us, unquote. Another great medieval theologian and scientist, Jean Buridan, said that when confronted by new phenomena, we should seek, quote, appropriate natural causes. That's why the Catholic Church today does not declare a miracle to be worthy of belief until it has excluded the likelihood of natural explanations. This brings us to the all-important theological distinction between primary and secondary causality. I think the failure to grasp this distinction is one of the main reasons many people see a conflict between science and religion. This distinction can be explained using a simple analogy. Consider the play Hamlet. In that play, the character Hamlet kills Polonius by stabbing him through a curtain. Now ask yourself this question. Did Polonius die because Hamlet stabbed him? Or did he die because Shakespeare wrote the play that way? Obviously, it's a silly question. For both are causes, but at different levels. The character Hamlet is the cause within the play of Polonius's death. The horizontal cause, or what theologians traditionally termed the secondary cause, whereas Shakespeare is the vertical or primary cause of the whole play and its entire plot, including, of course, Polonius's death. He would be, in theological terms, the primary cause. There's no competition or conflict between these two levels of causality. By analogy, the natural causes within the universe, which are studied by scientists and other people, are horizontal or secondary causes, while God, as the author of nature, is the vertical or primary cause. The analogy makes clear just how silly it is to treat evolution and creation as alternatives, as both fundamentalists and atheists do. Did this species of animal arise by natural processes, or because God wrote nature's script that way? Of course, both. That's why the Catholic Church has never condemned or opposed evolution. This also makes clear why scientific materialists are wrong to think that believers in God do so without evidence. For materialists, evidence means either directly observing something with our senses or inferring that something exists as a natural cause of what we observe, the way we observe a compass needle move and infer that there's a magnetic field. Obviously, God cannot be seen in either of these ways, for he is neither a part of nature, which could be sensed, nor a natural cause. And yet God is a cause, the ultimate cause. He is not a cause within nature, but the cause of nature. Thus, nature gives evidence of God in the same way a play or novel gives evidence of its author, even if the author does not make an appearance within the book. Now let's turn to the materialist historical critique of religion. The idea that Christianity and the Catholic Church in particular opposed science and tried to hold it back is called by historians the conflict thesis. It has been completely discredited by historians of science. It is a myth, pure and simple, whose roots lie in the Enlightenment and the contempt many of its thinkers had for revealed religion. Its growth was aided in Catholic countries by anti-clericalism and in Protestant countries by anti-Catholic prejudice. The conflict thesis was popularized by two enormously influential books written in the late 19th century. The History of the Conflict Between Science and Religion by John William Draper, and A History of the Warfare of Science with Theology in Christendom by Andrew Dixon White, who happened also to be the first president of Cornell University. These books are dismissed by scholars today as full of errors of fact and interpretation and historically worthless. One eminent historian calls Draper's book, quote, a thinly disguised anti-Catholic rant. The scientific revolution, which took place in the 17th century and gave rise to modern science, did not occur in a vacuum, and it did not occur in opposition to revealed religion. In fact, most of its great figures were devout Christians. Copernicus, whose work sparked the scientific revolution, was an official of the Catholic Church. Johannes Kepler, famous for his 3 laws of planetary motion, was a devout Lutheran who announced the discovery of one of his laws with these words, I thank thee, Lord God, our Creator, that thou hast allowed me to see the beauty in thy work of creation. Galileo remained a devout Catholic throughout his life. He had himself carried, when he couldn't walk anymore late in his life, he had himself carried to Mass. Descartes, whose work in mathematics was foundational for modern science, believed in God and the reality of the spiritual soul. Blaise Pascal was not only a mathematician and physicist of genius, but a man whose life was transformed by an intense mystical experience, and who wrote in defense of Christian belief and against skepticism. Robert Boyle, the first modern chemist, left a large sum of money to endow a series of lectures whose purpose was to combat the ideas of notorious infidels, which meant atheists. And Isaac Newton, the greatest of them all, spent as much time on theological and scriptural studies as he did on science. All of them saw their work as showing the beauty of God's creation rather than as supporting atheism. And this was true long beyond the 17th century. For example, the 2 greatest physicists of the 19th century, Michael Faraday and James Clerk Maxwell, were exceptionally devout Christians, even by the standards of their day. Moreover, the scientific revolution did not spring out of thin air. Its foundations were laid in the universities of medieval Europe, as has been strongly emphasized by the eminent historian of science, Edward Grant. It was in those universities that for the first time in human history, science was studied and taught on a continuous basis from generation to generation by a stable community of scholars. That is where science was first institutionalized, as Grant put it. These universities produced hundreds of thousands of graduates who were introduced to scientific questions and from whose ranks scientific talent could emerge. The scientific community and scientific public, these universities created were the soil in which the seeds of the scientific revolution germinated. By the end of the Middle Ages, there were 100 universities in Europe. I don't know if I mentioned that. A little-known fact, which dramatically illustrates the positive role the Catholic Church has played in the development of science, is the large number of Catholic priests who made major discoveries. We Catholics have our litanies. What follows is not a litany of saints, though there are a couple of saints among them, but a litany of priest-scientists. For reasons of time, I can only mention a few of the most outstanding. Okay, so I guess here, yes, there we go. In the Middle Ages, there were St. Albert the Great. Leave that up there for us. Oh, I guess we can. Robert Grosseteste, Thomas Bradwardine. Well, here, leave it here. I don't have a picture of Bradwardine. I guess he was camera shy. And Nicholas Orem, all bishops, by the way. Now, St. Albert the Great did original work of he was, by the way, St. Thomas Aquinas' teacher. And he did original work of observation and classification in botany and zoology. The Dictionary of Scientific Biography calls his work on vegetables and plants, quote, a masterpiece for its independence of treatment, its accuracy and range of detailed description, its freedom from myth, and its innovation in systematic classification. Robert Grosseteste studied the refraction of light and came up with a geometrical theory of how lenses magnify images. It was essentially correct. Bradwardine showed that Aristotle's ideas on the relation of force and motion were not self-consistent and developed his own mathematical theory of them. His was one of the first attempts to give a mathematical formula to describe a physical process. That's right. That's a diagram from one of Bradwardine's treatises. So I guess the next one is Orem, Nicholas Orem. Orem was a genius who made many contributions to mathematics and physics. He was also a polymath. He did work in economics. Some say he was the greatest economist of the Middle Ages. He did work in musicology and other fields. But his work in mathematics and physics was far ahead of its time. For example, he was the first person to graph physical quantities, thus anticipating by 3 centuries some of Descartes' ideas. And he used that method to prove an important theorem about uniformly accelerated motion. Based on this theorem, Orem correctly speculated that the speed of a falling body is proportional to the time that it has fallen, which anticipated Galileo's famous law of falling bodies. So in the next slide, there's a diagram. This is a diagram from one of Orem's treatises, proving the theorem about accelerated motion. And on the next slide, you see a diagram from Galileo's work 300 years later with a very similar diagram to prove the same theorem. And it's very likely, though it's very difficult to prove such a thing, but it's very likely that Galileo knew about and was influenced by Orem's work. In the 17th century, there were many important priest-scientists. This was the century of the scientific revolution, including Niels Stenson, Marin Mersenne, Christoph Scheiner, Giambattista Riccioli, Francesco Grimaldi, Benedetto Castelli, and Bonaventura Cavalieri. So let's see, the next one. Next one. Stenson. Niels Stenson, also known as Steno, was a Danish Lutheran. He converted as an adult to Catholicism, became a priest, and eventually was made a bishop. As bishop, he was noted for his asceticism and his solicitude for the poor. He was beatified by Pope John Paul II. Stenson was the greatest anatomist of his time. He made major discoveries in that field. Several features of the body are named after him, such as Stenson's duct, Stenson's vein, and Stenson's foramina. But his greatest contribution, for which he is considered a founder of the science of geology, was developing the correct theory of the origin of sedimentary rock, sedimentary rocks, indeed understanding for the first time that these rocks had originally been underwater and formed from sedimentation, and the origin of fossils. His theories unlocked the history of the Earth. He's considered one of the principal founders of the science of geology. In fact, sometimes if you see the names of the founders of geology listed, Stenson is often listed first. This slide up on the right is what I guess called a Google Doodle that Google put up on Stenson's birthday. And if you can see from that distance, there are layers, sedimentary rock, and little fossils embedded in the layers. So he is the person who first understood really fossils and sedimentary rock. Next slide is Mersenne. Marin Mersenne is considered the founder of acoustics for fundamental discoveries in the theory of sound and vibrations. His religious house became a meeting place of famous scientists, and his voluminous correspondence with other scientists was an important means by which they learned about each other's work. They didn't have scientific journals in those days, they didn't have scientific conferences, and they didn't have the internet. To a large extent, the way scientists found out what was going on was by corresponding with other scientists, and Mersenne was kind of a hub of that. The Dictionary of Scientific Biography calls him one of the, quote, architects of the European scientific community. He did other things too, but I won't mention. He did important work on the theory of telescopes, for example. He was one of the founders of the Paris Academy, one of the first scientific academies in Europe. Next slide is Scheiner. Here's a picture of the Jesuit astronomer Christoph Scheiner. Scheiner and Riccioli and Grimaldi, who I'm going to talk about now, were Jesuits. The Jesuits have a great tradition in astronomical research, which continues to this day. As you know, the very calendar we use, the Gregorian calendar, was developed by a Jesuit astronomer. Christoph Scheiner was one of the discoverers of sunspots and made the most detailed study of them. So the next one, here's a picture of him in his observatory actually studying sunspots. And on the next slide, this is an image from a very thick treatise he wrote on sunspots. And what you see is these little blotches on the face of the sun traveling across the sun at an angle, and there's one of those blotches for every day. There's a gap because that was a cloudy day in which he couldn't observe. And then on the bottom you see 6 months later the sunspots marching across the face of the sun. This, by the way, shows that the sun is rotating on a tilted axis. Giambattista Riccioli, well, among other scientific contributions, discovered the first binary star, made one of the first star catalogs. He also developed ways of measuring time precisely using pendulums, which was very important in scientific research. Together with Francesco Grimaldi, he made the first map of the moon's surface, and that's actually part of their map. I should mention that there's a tradition of naming, because of all the work that Jesuit astronomers did, especially on the moon, about the moon, that many of the largest craters on the moon are named after Jesuit astronomers. Okay, so let's see. Grimaldi, who helped Riccioli, is on the next slide. So there's Francesco Grimaldi, discovered an extremely important physics phenomenon called the diffraction of light. Anyone who studied physics at high school or college or graduate school level knows how important this phenomenon is. It shows that light is a wave. Since we now know that all matter is made up of waves, diffraction is a very important phenomenon in all branches of physics. I show some pictures from the internet of some diffraction phenomena. The colored bands you see on DVDs and CDs are a diffraction phenomenon. So when you see those, think of Father Grimaldi in the 1600s who first discovered these effects. The next person, Benedetto Castelli, is considered the founder of hydraulics. He was a friend and pupil of Galileo and a teacher of two important scientific figures, Bonaventura Cavalieri and Evangelista Torricelli. So Cavalieri, there's a picture of his book on the measurement of water currents. The next person, now that's Bonaventura Cavalieri. Cavalieri was himself a priest and made important contributions to the development of integral calculus. You see on the slide a quote from Leibniz. Leibniz and Newton, recall, were the people credited with discovering calculus. And Leibniz wrote, "In the sublimest of geometry, the initiators and promoters who performed a yeoman's task were Cavalieri and Torricelli. Later others," meaning Leibniz himself, progressed even further using their work. So he's a very important figure in the history of mathematics. In the 18th century, there was Lazzaro Spallanzani, one of the leading biologists of that century. His contributions to biology were very varied and numerous. He was the first to explain the process of digestion. He showed that fertilization in mammals occurred through the union of sperm and egg. He even did some unsuccessful experiments trying to breed various animals, such as dogs and cats. Not every scientific experiment leads to something. He studied echolocation in bats and the regeneration of limbs in lower animals. Among his most important work was a series of experiments disproving the theory of spontaneous generation of life. Everybody knows about Louis Pasteur's experiments 100 years later, but Pasteur studied and based some of his work on the work of Abbé Spallanzani. There was René Just Oey, the next person, who is considered the founder of crystallography, and here's a picture of him holding a crystal and some calipers. In the 19th century, there was Giuseppe Piazzi, an astronomer who discovered the first asteroid. Actually, they keep reclassifying things. So now Pluto is a minor planet, and Ceres is a minor planet. There was a short period of time where Ceres was considered a planet, and it was the first planet discovered since antiquity. It was discovered by Piazzi. It's now been demoted. Well, soon after he discovered it, the idea of asteroids was developed, and it was demoted to the status of an asteroid. So now I think it's been upgraded to a minor planet. Then there was, next is Pietro Angelo Secchi, a Jesuit, who is considered one of the founders of modern astrophysics for pioneering the use of spectroscopy in the study of stars and the sun. He made the first classification of stars based on their spectra, which is the basis of our present classification. A beautiful symbol of the harmony of faith and science is the fact that Secchi did some of his groundbreaking research using an observatory built on the top of the Church of Sant'Ignazio in Rome. And I can't resist showing you. It probably doesn't come out in PowerPoint, but the next slide, well, can't see the colors, but there's a magnificent fresco in that church. If you ever go to Rome, I recommend you go and look at it. But as I say, every astrophysicist knows of the work of Secchi. Then there was Bernard Bolzano, a Czech priest who helped put modern mathematics on a more rigorous foundation. Anyone who's studied advanced math has probably heard of the Bolzano-Weierstrass theorem, for example. And here's a quote from the Stanford Encyclopedia of Philosophy saying he was an outstanding mathematician and possibly the greatest logician in the time between Leibniz and Frege. And of course, there was Gregor Mendel, the founder of genetics. In the 20th century, there was Julius Newland, who was a professor at Notre Dame, who did work that led to the development of neoprene, the first synthetic rubber. And last but not least is the person I mentioned at the beginning of the talk. This is Georges Lemaitre. Georges Lemaitre was the founder of the Big Bang Theory. Not the TV show, but the theory. Okay? This is the central idea in modern cosmology, and most people are not aware that the founder of the Big Bang Theory was a Catholic priest, a physicist who was a Catholic priest. What a glorious record of achievement. Professor Lawrence Principe of Johns Hopkins University, who's both a chemist and a noted historian of science, has written, quote, "The Catholic Church has been probably the largest single and longest-term patron of science in history." Okay, so for the rest of my talk, and I might have to abbreviate it because I think I went on too long about the pre-scientists, is to deal with the third strand of the materialist critique of religion. The notion that many of the greatest discoveries of modern science have undermined or debunked the traditional Christian and Jewish view of the universe, of human beings, and of our place in the universe. As things stood 100 years ago, this view had some plausibility, but much has changed since then. There have been several major discoveries or developments, especially in physics, that seem more consonant with the Christian and Jewish conception of the universe and of man than with the materialists. I'd like to discuss 4 or 5 of them. In each case, I'll mention the earlier discoveries that had seemed to favor the materialist's view, and then the more recent discovery or development that points the other way. The first had to do with the structure of the cosmos. We've all heard how Copernicus overturned the religious picture of the cosmos by showing that human beings are not at the center of it, and how later discoveries demoted us even further by showing that Earth is just a tiny speck lost in the vastness of space. Actually, however, The idea of the earth as the center of the universe did not come from the Bible, but from ancient Greek science, specifically Aristotle and Ptolemy. Nor was the center a place of honor in Aristotle's cosmos. On the contrary, it was the lowliest place, and the further away from the center things were, the more noble and exalted they were. There was one idea about cosmology that did enter Western thought from biblical revelation, but it was not about space and whether it had a center. It was about time and whether it had a beginning. The pagan thinkers of antiquity, including Aristotle, conceived of the universe as having had no beginning. Modern atheists have also tended to prefer this idea. Until about 100 years ago, almost every indication from science seemed to support this idea. Physicists discovered that the amount of energy never changes. It cannot be created or destroyed. Chemists found that the number of atoms does not change in a chemical reaction. In Newtonian physics, time extended infinitely into past and future, just as space extends infinitely in all directions. Almost everything suggested that matter, energy, space, and time had always existed and always would. There was no hint of a beginning. The idea of a beginning came to be seen as outdated religious mythology. The Nobel Prize-winning chemist Svante Arrhenius said in 1911, quote, "The opinion that something can come from nothing is at variance with the present-day state of science, according to which matter is immutable." The Nobel Prize-winning physicist Walter Nernst declared, quote, "To deny the infinite duration of time would be to betray the very foundations of science," unquote. But in 1916, Einstein proposed his theory of gravity, called general relativity, and everything changed. In the 1920s, the Belgian theoretical physicist Georges Lemaitre, the priest we saw a minute ago, realized that the equations of Einstein's theory of gravity could describe a universe whose space is expanding. Combining this with the observation by astronomers that distant galaxies were receding from us, Lemaitre proposed what is now called the Big Bang theory. It took a long while to gain acceptance, partly because of philosophical prejudice against the idea of a beginning, but also for certain technical scientific reasons. But in time, the evidence grew overwhelming that the hypothesized Big Bang did occur about 14 billion years ago. In the standard Big Bang theory, everything began at that point: matter, space, and time itself. It is possible that something preceded the Big Bang, and it wasn't the absolute beginning of the universe, but perhaps only the beginning of some phase in the history of the universe. There are, however, strong, very strong theoretical arguments, to think that the universe must have had an absolute beginning at some finite time ago. If not at the Big Bang, then at an earlier point. So science now strongly supports an idea that came from biblical revelation and was dismissed both by the pagans of antiquity and modern materialists, and for a long time seemed contrary to science. The second development I'll speak about has to do with the evidence of design in nature. Religious believers have always seen evidence of design: the starry heavens, the forms of living things, and other wonders of nature were seen as having been fashioned by the hand of God. Modern science seemed, however, to undercut this idea by showing that they were the result of mechanisms that depended upon a combination of impersonal laws and blind chance. Whereas Genesis spoke of God placing the sun and moon in the firmament, astrophysics showed that they condensed from swirling clouds of gas and dust under the attraction of gravitational forces. Darwin showed how the intricate structures of living things could arise from natural selection acting upon random mutations. When Napoleon asked the great mathematician and physicist Laplace why God was never mentioned in his great treatise on celestial mechanics, Laplace famously replied that he had, quote, no need of that hypothesis. The laws of physics had displaced God. Now, this was a new way of looking at the laws of nature. From ancient times, it had been argued, as we've seen, that the lawfulness of nature pointed to a lawgiver. But now it was argued by some that the laws of nature in and of themselves constitute a sufficient explanation for the order of nature. And this does seem to make a certain amount of sense if you think about the shapes or patterns that we see in tangible objects, in things that we can look at with our eyes, such as crystals or seashells or sunflowers or the motions of heavenly bodies. Consider, for example, the solar system. It exhibits many striking mathematical patterns, 3 of which were discovered by Johannes Kepler. He found that each planet follows an elliptical path, with its speed varying in such a way that the line from planet to sun sweeps out equal areas and equal times. He also discovered a simple algebraic relation between the period of a planet's orbit and its distance from the sun. All of these and many other patterns in the solar system can be explained by the laws of Newtonian physics. Does that mean, however, that the laws of Newtonian physics have explained the existence of cosmic order? No, it's quite the reverse. For how did Newton explain the order of the solar system? By appealing to deeper mathematical order that applies throughout the whole universe. It showed that Kepler's 3 laws of planetary motion follow from Newton's more fundamental laws of mechanics and gravity. But Newton's laws describe an order far grander and more impressive than the laws of Kepler. There was more cosmic order to explain after Newton than before. And where does the greater order discovered by Newton come from? Newton's law of gravity comes from the yet more fundamental laws discovered by Einstein, Einstein's equations of general relativity. And lo and behold, the mathematical order described by Einstein's laws is even more splendid, beautiful, and profound than that found by Newton. And the process continues. It's believed that Einstein's laws of gravity in turn can be derived from yet more beautiful and profound laws, very likely those of so-called M theory or superstring theory. This is what the progress of physics, especially in the 20th century, has shown with ever greater clarity. The deeper we probe into the hidden workings of the physical world, the richer, more intricate, and more magnificent the mathematical structure we find. And we find this beautiful structure in the mathematical laws themselves. All of this has changed the context in which we think about design in nature. When the questions that scientists asked were simply about shapes or patterns seen in tangible things, however beautiful, it may have seemed naive to speak of them as fashioned by the hand of God. They could be accounted for by the operation of the laws of physics. But now that the deepest laws of physics themselves have been found to form a magnificent edifice of great subtlety, harmony, and beauty, the question of a cosmic designer has returned with greater force than ever. In 1931, the great mathematician and physicist Hermann Weyl gave a lecture in which he said the following, quote, "Many people think that modern science is far removed from God. I find, on the contrary, that it is much more difficult today for the knowing person to approach God from history, from the spiritual side of the world, and from morals, for there we encounter the suffering and evil in the world, which it is difficult to bring into harmony with an all-merciful and almighty God. In this domain, we have evidently not yet succeeded in raising the veil with which our human nature covers the essence of things. But in our knowledge of physical nature, we have penetrated so far that we can obtain a vision of the flawless harmony that is in conformity with sublime reason." Minucius Felix spoke of the providence, order, and law in the heavens and on earth. The deeper we have penetrated into the structure of the universe, the more order and law we have seen, so that the ancient argument for God from the order of nature has been strengthened, not weakened, by scientific progress. The third development I'll speak of has to do with whether there is purpose in nature. It's easy to regard natural things as having purposes. For example, the sun seems to exist to provide the energy that plants need to grow, and rain provides the water. From this, it's a short step to ascribing such purposes to a plan existing in the mind of God. And the pre-modern science of Aristotle was based on teleology, that the idea that natural processes and entities are directed toward ends or goals. Heavy objects fall in order to reach the center of the earth. Living things heal from injury in order to reach the goal of bodily health and wholeness. But this teleological approach to science was set aside by the scientific revolution, at least in physics, and replaced by a mechanistic approach. Events were no longer seen as being drawn toward future goals, but driven blindly along by past and present causes. Modern physics explains how the sun formed and generates energy, without any reference to ends. In the perspective of modern physics, neither the sun nor its energy are for anything, such as supporting life on Earth. Rather, life on Earth takes advantage of the energy that happens to be there. Darwinian evolution has pushed this mode of explanation further. To put it simply, trees do not exist so that monkeys can climb them, but rather some creatures adapted to the presence of trees by evolving the ability to climb. But the idea of purpose in nature has staged a comeback. And again, it's not so much at the level of tangible things, trees or monkeys, or their structure, but at the level of the laws of physics themselves. Over the last 40 years or so, physicists have become increasingly aware that many features of the fundamental laws of physics seem arranged so as to make life possible. These are sometimes called anthropic coincidences. I could give dozens of examples. I'll mention just a few. Example 1. If the world did not obey the principles of quantum mechanics, atoms and molecules would not be stable building blocks with well-defined properties out of which you could build complex structures like living things. 2. If the so-called down quark were lighter than the so-called up quark, instead of heavier, as it is, then ordinary hydrogen on which all life depends would be radioactively unstable. We don't understand at the moment why the up quark is lighter than the down quark. It's a 50-50 proposition, and fortunately it came out in a way that made life possible. Number 3, if the so-called strong force, which holds nuclei together, were even a small fraction weaker than it is, a crucial nucleus called deuterium could not exist, and the nuclear reactions that power the sun and similar stars would not take place, depriving Earth of the energy needed for life. Moreover, the fusion reactions, the fusion processes that occur in stars and which were required to form all the elements of the periodic table, except the very smallest ones, would not have been possible. So again, if the strong force was just a little bit weaker than it is, no stars like the sun, most of the elements of the periodic table would not exist. Number 4, we live in a universe that has 3 macroscopic space dimensions. There might be some others that are subatomic in scale. In some theories like superstrength there are. But we have 3 large or macroscopic space dimensions. If the number of macroscopic space dimensions were greater than 3, gravity would act differently and in such a way as to not allow planets to orbit stars. Planets would either fly off into space or plunge into the stars. Similarly, atoms would not exist. Electrons would plunge into the nucleus or fly off. So it's very important that you have no more than 3 space dimensions. There are other reasons you don't want to have fewer than 3 space dimensions. There are things that happen if you have fewer than 3 space dimensions that would also militate against the existence of life. So 3 is a very special number of space dimensions. You can go on and on, giving examples of such features. The most obvious way to explain them is to say that whatever mind conceived of the laws of physics did so with the purpose that life should arise. There's an alternative explanation called the multiverse idea, which I won't try to explain because we're running out of time, but I will in the Q&A if someone wants. If the universe is a multiverse, as it well may be, it could explain some, though in my view not all, of the anthropic coincidences. But it wouldn't dispose of the evidence for purpose in the fundamental structure of nature's laws. Since a multiverse, to have a universe which is a multiverse, that itself requires that the fundamental laws be very special. So one way or the other, the laws of physics have to be very special if you want to have a universe in which complex biological organisms can arise. By the way, the vast size of the universe, which some people see as a sign of human insignificance, is actually one of the things which makes life possible in our universe. The astrophysical and biological processes by which life arose required billions of years to unfold. And according to Einstein's theory of gravity, a universe which is to last for billions of years must attain a size of at least billions of light years across. A universe that never got larger than a human scale of distance, say thousands of miles across, would last only for a small fraction of a second. Now, I think since I have 4 minutes left by my counting, I am going to race through the rest of the last couple of, well, actually only have a few transparent pages. The fourth development I'll discuss has to do with the issue of determinism and free will. For 300 years, all indications were that the mathematical laws of our universe are deterministic. That is, given the state of the universe at one time, the equations would uniquely determine its whole future development, as it was famously stated by Laplace 200 years ago. And this was considered a big blow to religion, because it seemed to rule out the possibility of human free will. Because if one were to know, or some powerful intellect were to know the state of the physical world, say, 1 billion years ago, it could be calculated from that everything that would happen thereafter, including everything that we did. And if anything seems solidly supported by science 100 years ago, it was physical determinism. But then, to the astonishment of physicists, determinism was overthrown by quantum mechanics in the 1920s. For it turned out that a fundamental feature of quantum mechanics is that its equations do not, generally speaking, predict what will happen, but only the relative probabilities of various future outcomes. That has seriously weakened the physics objection to the possibility of free will. To quote Hermann Weyl's 1931 lecture again, "We may say that there exists a world causally closed and determined by precise laws, but the new insight which modern quantum physics affords, opens several ways of reconciling personal freedom with the laws of nature. It would be premature, however, to propose a definite and complete solution of the problem. We must await the further development of science, perhaps for centuries, perhaps for thousands of years, before we can design a true and detailed picture of the interwoven texture of matter, life, and soul. But the old classical determinism of Hobbes and Laplace need not oppress us longer." The fifth and last development I won't discuss has to do with the question of whether the human mind, whether mind, and particularly the human mind, is reducible to matter, as materialists claim. There are two very profound discoveries in the 20th century that give hints or are the basis of arguments that this is not the case, that our minds are not just the functioning of a sophisticated mechanism. One of these is quantum mechanics, again, and the other is a theorem in mathematical logic called Gödel's theorem. It turns out that if you understand quantum mechanics in the traditional way, you run into inconsistencies or vicious circles if you try to say that everything is described by the laws of quantum mechanics, including the minds of observers such as ourselves. And the reason is actually it's very subtle, and it would take a long, long time to explain, but the gist is the sort of how it works is this. Quantum mechanics deals with probabilities at a very deep level. Probabilities have to do with someone's state of knowledge. If you know what's going to happen, you don't have to use probabilities. If you don't know what's going to happen, you have to use probabilities. So probabilities of events pertain to someone's state of knowledge. In quantum mechanics, that someone is traditionally called the observer. If you talk about the state of knowledge, you're talking about mind and consciousness. So that's how, in quantum mechanics, the whole question of the relation of mind and consciousness to the physical world arises. And as I said, it turns out that if you try to say that not only the system that's being measured, but the observer who's making the measurements is described by the laws of quantum mechanics, you run into some logical problems. And I'll just quote a few famous physicists. Heisenberg himself said, for example, the mathematics of quantum mechanics, quote, represents no longer the behavior of physical systems, but rather our knowledge of their behavior, unquote. Sir Rudolf Peierls, a leading 20th century physicist, said, the quantum mechanical description is in terms of knowledge, and knowledge requires somebody who knows. The Nobel Prize-winning physicist Eugene Wigner said, the very study of the physical world led to the conclusion that the content of the consciousness is an ultimate reality. That is as important and basic as matter. Peierls said, the premise that you can describe in terms of physics the whole function of a human being, including its knowledge and consciousness, is untenable. And Wigner said, flatly, materialism is not, quote, logically consistent with present quantum mechanics. So there's some rather significant, eminent voices who make anti-materialist arguments based upon the logic of quantum mechanics. And I think I'll skip the part on Gödel's theorem, but there's a powerful theorem in mathematics that called Gödel's theorem that shows that the process of coming to know mathematical truth is not simply a matter of mechanically following rules, let's put it that way. And so from this it has been argued by some philosophers and an eminent mathematician named Sir Roger Penrose that the human mind, at least when it's doing mathematics, is doing something that it cannot be reduced simply to mechanical rule following of the kind that computers engage in. Okay. So we see then that the discoveries of the 20th century have shown us a world that looks more like the world of Christian faith than did the science of 100 years ago. We find that the universe probably did have a beginning after all. We find that the laws of nature have a richness and profundity of mathematical structure that bespeak design. We find in those laws many features that suggest that the universe has a purpose, which is to give rise to life. We find that the determinism that seemed to refute the possibility of free will has been overthrown. And we find that some of the deepest discoveries of physics and mathematics suggest there's more to the human mind than physics or mathematics can describe. So I've covered a lot of ground, and I hope I've shown that the Catholic Church has been a friend of modern science and has, in turn, nothing to fear from modern science. The real antagonist of religion is not science itself, but scientific materialism, a reductive philosophy that comes from a blinkered view of reality, and indeed a blinkered view of science itself. Thank you.